Hi, and welcome to another lesson. As promised, we're going to learn about alkali metals in details. And alkali metals are simply elements in group 1. They include lithium, sodium, and potassium. And here we're going to learn about the physical and the chemical properties of alkali metals. On the physical properties, number 1, you have gradation in the size of the atom and the ion. The atomic radius increases down the group. Then elements in group 1 have one more occupied energy level than the preceding member in the group. For example, sodium and lithium. Sodium has one more occupied energy level than lithium. Then on the second point, you have the ionic radius increases down the group. Which is also similar to the atomic radius. Atomic radius and ionic radius are different. Atomic radius is just when the atom is just like that, while ionic radius is when the metal or the element loses one electron to form an ion. Number 2 property is the melting point and boiling point, whereby the melting point and boiling point decreases down the group. And the reason for that is that the strength of the forces holding the atoms together depend on the size of the atoms. That is, the smaller the atom, the stronger the force of attraction from the nucleus. For example, lithium has a stronger force of nuclear attraction compared to sodium and potassium, which means that lithium has a higher melting point and boiling point compared to sodium and potassium. And sodium has a higher melting point and boiling point compared to potassium. So the first one is lithium. Number 3 property is electrical conductivity, which is which means that the alkali metals are good conductors of electricity and also heat due to the delocalized electron. As you can see from the drawing, which have drawn sodium, it has one delocalized electron in its outermost energy level. Number 4, we have ionization energy. And the ionization energy is simply the minimum amount of energy that is required to remove an electron from the outermost energy level. So, lithium, remember we said that lithium has a stronger force of a strong nuclear force of attraction, which means that lithium has a higher ionization energy compared to sodium and potassium. This simply means, like when I say that it has a stronger force of nuclear attraction, it means that it simply means that I require you you'll require a lot of ionization energy so that you can dislodge that one electron in lithium compared to sodium and potassium. Number 5 property is electropositivity, which is the ease of losing electrons. Again, we look at the force of nuclear attraction. Lithium, sodium, and potassium. Potassium has a higher electropositivity compared to sodium and lithium, which means that potassium can easily lose that one electron compared to sodium and lithium. And lithium is the least element that is the least, like it does not have a lot of ease of losing the electron. Next, we're going to be learning about the chemical properties. Number 1 is reaction with water. And in reaction with water, alkali metals react with water to form metal hydroxide and hydrogen gas. For example, let's go down to the chemical equation down there, where it says that sodium reacts with water to form sodium hydroxide and hydrogen gas. There should be a symbol of gas down there on the equation. So, when sodium reacts with water, this is commonly tested, you may be asked, what is observed when sodium reacts with water? There's also a reaction of potassium with water, but I didn't include it. Firstly, so we start with sodium. Sodium, that's when it reacts with water, that's on the surface of the water as it melts into a silvery ball. Then a hissing sound is produced, a colorless gas which extinguishes like fire, sorry, not fire, which extinguishes a glowing, sorry, not extinguishes, which lights up a glowing wooden splint is produced, which is oxygen. Number two property is burning of alkali metals. As you can see there, sodium burns with a golden yellow flame, while potassium burns with a lilac flame. Number three is reaction with air. Sodium reacts with oxygen to form sodium oxide. That is in limited amount of oxygen. And number two, sodium reacts with oxygen to form sodium peroxide. That is in excess amount of air. And kindly do not forget to write the symbols down there. I forgot to do that, sorry. So we have sodium oxide and sodium peroxide, which can be differentiated by adding water. And when water is added to sodium peroxide, a gas which is oxygen is produced, and also sodium hydroxide is produced. When added to sodium oxide, only sodium hydroxide alone is formed. Yeah, I think that's where we'll stop for today. Thank you for your time. Yeah, thank you.